Hi everyone. Yesterday we already discussed some standard integrals. The first one of them, integral f dash of x f of x into dx. This is the one of the important standard result. The integral f dash of x upon f of x dx is the log mod of f of x plus c. After that, integral f dash of x by root of f of x dx. This is the 2 into root of f of x plus c. These two are the very important. First of all, the integral f dash of x by f of x into dx is the log mod of f of x plus c. Then the integral f dash of x upon root of f of x dx equals to 2 into under root f of x plus c. Now the third one, e power f of x into f dash of x into dx. That is the form e power f of x plus c. Then finally the integral f of x whole power n into f dash of x dx. So this is the f of x whole power n plus 1 upon n plus 1 plus c. These are the four standard integrals. So already we have to know that yesterday we discussed these four standard results. Today we are going to discuss duster. So here, first of all, we have to find the integral of tan x. First we have to evaluate the integral tan x dx. Is it clear? Now we evaluate the integral tan x dx. That is the log mod of secant of x plus c. This is the integral of tan x. Are you clear? We can write the integral of tan x dx is the log mod of secant x plus c. Now its solution is integral of tan x. We have to know that tan x is the form of sin x by cos x. Tan x is the sin x by cos x. Therefore, tan x is the sin x by cos x into dx. Now we have to know that the integral f dash of x by f of x into dx is the log mod of f of x plus c. This is the log mod of f of x plus c. Integral f dash of x by f of x dx is the log mod of f of x plus c. Therefore, we have to know the derivative of cos x is the minus sin x. Therefore, we are taking minus into minus is the plus. Therefore, we can write minus into minus. That means sin x upon cos x. So, is it clear? This is compared with the denominator is the f of x, numerator is the f dash of x. Therefore, we can write this is the f dash of x, this is the f of x. The derivative of the cos x is the minus of sin x. F dash of x by f of x is the log mod of f of x. Therefore, now we can write minus of log mod of f of x is the cos x plus c. Now this is log mod of, now this is, we know that the logarithm formulas, log a power m is the m log a. Log a power m is the m log a. Therefore, now this is the, we can write, this can be written as cos x whole power minus 1 plus c. Therefore, we can write the log mod of cos x power minus 1 is the 1 by cos x plus c. 1 by cos x. We know that the reciprocal of the cos is the secant. Secant x is the 1 by cos x. Secant x is the 1 by cos x. Therefore, now we can write this is log mod of secant x. Log mod of secant x plus c. This is the formula. Log mod of secant x plus c. Therefore, the integral of tan x dx is the log mod of secant x plus c. Now the another one is Another one is integral of tan x dx. Now this can be written as, we know that the derivative of the secant x is the secant of x into tan x. Now this can be written as secant x into tan x whole by secant x. In this case we have to take only into secant x and divided by secant x. We have to take into secant divided by secant. That means this is compared with f dash of x by f of x. Since the derivative of the secant x is the secant x into tan x, the derivative of the secant x is the secant x into tan x. Therefore, now we have to compare with this one f dash of x by f of x. When it is the integral is in the form of f dash of x by f of x, then we know that that is the formula of log mod of f of x. Therefore, we can write log mod of f of x. F of x is the secant x plus c. This is our required solution. That is the integral of tan x is the log mod of secant x plus c. Is it clear? Now we are going to the next one, integral of cot x. Integral of cot x dx. Integral of cot x dx is the log mod of, integral of cot x dx is the log mod of sin x plus c. The integral of cot x dx is the log mod of sin x plus c. Therefore, this is the second one. We know that cot x is the cos x by sin x. Cot x is the cos x by sin x. Therefore, now this is cos x by sin x into dx. What is this one? F dash of x. Again we are getting f dash of x by f of x. Therefore, integral of f dash of x by f of x into dx is know that log mod of f of x plus c. Therefore, we can write here the derivative of the sin x is the cos x. The derivative of the sin x is the cos x. Therefore, is it compared with f dash of x by f of x? Log mod of f of x. F of x is the sin of x. Integral constant is the c. This is the integral of cot x into dx is the log mod of sin x plus c. Integral of tan x dx is the log mod of secant x plus c. This is the integral of cot x is the log mod of sin x plus c. Now we are going to discuss about the integral of secant x. So integral of secant x dx. Therefore, the integral of secant x is the integral of secant x dx is the form log mod of secant x plus tan x. Log mod of secant x plus tan x plus c. This is the first form. Log mod of secant x plus tan x, and another form is log mod of tan pi by 4 plus x by 2 plus c. This is the integral of secant x dx. One of the form is log modulus of secant x plus tan x plus c, and another one is the log mod of tan pi by 4 plus x by 2. Now its solution is we have to take integral of secant x dx. Integral of secant x dx. Therefore, this can be written as secant x plus tan x whole by secant x plus tan x. In the first step, we are taking into secant x plus tan x upon secant x plus tan x. We are taking the first step into secant x plus tan x by secant x plus tan x. Here we can write the secant into secant is secant square x. Secant into secant is the secant square x. Now this is secant x into tan x. Therefore, secant x into tan x whole by secant x upon secant x plus tan x. Everyone here observe why we are taking the multiplication and division with secant x plus tan x. That means we are getting the derivative of the tan x is secant square x, and the derivative of secant x is secant x tan x. That's why we are getting now f dash of x by f of x. Now this is complete one is in the form of f dash of x by f of x. Therefore, we have to know that f dash of x by f of x into dx is the log mod of f of x plus c. Therefore, here we observing the derivative of tan x is secant square x. The derivative of secant x is secant x into tan x. That's why this is the f dash of x by f of x. Therefore, we can write log mod of f of x. Log mod of f of x is the secant x plus tan x plus c. This is the log mod of secant x plus tan x plus c. This is the first formula. Now we prove that second one. We know that the reciprocal of the secant x is the cos x. Tan x is the sin x by cos x. Therefore, now we can write here the log modulus of secant x is the 1 by cos of x. Tan x is the sin of x by cos of x. Is it clear? The secant is the reciprocal of cos, that is 1 by cos x. Tan x is the sin x by cos x. We are looking the denominators are equal. Now we are taking the LCM is the cos x. Therefore, log of 1 plus sin x whole by cos x. 1 plus sin x whole by cos x. Therefore, now we have to think that the 1 is the form of sin square x by 2 plus cos square x by 2. But the sin x is we know that in the multiple and submultiple formulas, multiple angle and submultiple angles in the first year in the trigonometry, we know that sin 2a, 2 sin a cos a. The formula of sin 2a is the 2 sin a cos a. Sin a, 2 sin a by 2 cos a by 2. Cos 2a, cos square a minus sin square a. Cos a, cos square a by 2 minus sin square a by 2. Therefore, now we can write log modulus of 1 is the sin cos square x by 2 plus sin square x by 2. 1 is the formula cos square x by 2 plus sin square x by 2. Now we can write the sin x is the 2 sin x by 2 into cos x by 2. Therefore, now this is 2 sin x by 2 into cos of x by 2. What is the denominator is the cos x. We know that cos 2a, cos square a minus sin square a. But the submultiple angle cos a is the cos square a by 2 minus sin square a by 2. Now this can be written as cos square of x by 2 minus sin square of x by 2. Therefore, now we have to compare this one, a square plus b square plus 2ab. A square plus b square plus 2ab is the a plus b whole square. Now this is cos of x by 2 plus sin of x by 2 whole square whole by. So the numerator is in the form of a square plus b square plus 2ab. This is the a plus b whole square. But the denominator is a square minus b square, that have a plus b into a minus b. Now this is a plus b cos of x by 2 plus sin x by 2 into cos of x by 2 minus of sin of x by 2 modulus of. Now is it clear? The nr is the whole square is there, but the denominator is this one. Therefore, this is the 1 time, this is the 2 times. We know that a square is the a into a. 1 time cancel. Therefore, what is the remaining here? Cos x by 2 plus sin x by 2 upon cos x by 2 minus sin x by 2. This is we know that in the first year, log modulus of, we are getting the remaining one is cos of x by 2 plus sin x by 2. Cos of x by 2 plus sin x by 2 upon cos x by 2 minus sin x by 2. Cos of x by 2 minus sin of x by 2 plus c. This is the remaining. Now here we know that this is the formula of tan of pi by 4 plus x by 2. Tan of pi by 4 plus x by 2. But the nr and dr divided by both numerator and denominator both are divisible by cos x by 2. That means cos x by 2 by cos x by 2 is the 1. Sin x by 2 by cos x by 2 is the tan of x by 2 whole by this is also 1 minus of sin x by 2 by cos x by 2 is the tan of x by 2 plus c. Is it clear? We can write tan x by 2, cos by cos 1, sin by cos tan, cos x by 2 by cos x by 2 1, sin x by 2 by cos x by 2 tan x by 2. Suppose if you forget it, you can write tan is the sin by cos. We are taking the LCM, again getting this step. Therefore, this is, we know that log mod of tan of pi by 4 plus x by 2 plus c. Is it clear? This is the formula of tan of pi by 4 plus x by 2. This is the tan of a plus b. Tan of a plus b. Tan a. Tan a means tan 45. Tan 45 is the 1 plus tan b is the tan x by 2. Tan a plus b is the tan a. Tan 45 is 1 plus tan b is the tan x by 2 whole by 1 minus tan a into tan b. 1 into tan x by 2 is the tan x by 2. Now this is the tan of a plus b. Tan a plus tan b by 1 minus tan a into tan b. Tan 45 into tan x by 2. That is our required answer. Log mod of tan pi by 4 plus x by 2. Is it clear? Just wait. Okay. So now we have find the integral, evaluate the integral cosecant x, integral cosecant x dx. So now we are going to discuss about the integral cosecant x into dx. Therefore, this is the log mod of cosecant x minus cot x. Log mod of cosecant x minus cot x. Log mod of cosecant x minus cot x plus c, and another one log mod of tan x by 2. Log mod of tan of x by 2. Log mod of tan of x by 2 plus c. This is the integral of cosecant x into dx. The first one is log mod of cosecant x minus cot x plus c. Another one is the log mod of tan x by 2 plus c. Therefore, now here the integral cosecant x dx. Integral cosecant x dx. Similarly, the last one we have to multiple with the cosecant x here. The cosecant x minus cot x division with also cosecant x minus cot x into dx. Is it clear? In the first step, we have to take into cosecant x minus cot x divided by cosecant x minus cot x. After that, we have to multiple with cosecant x. Therefore, now this is cosecant x into cosecant x is the cosecant square x. Cosecant into cosecant square x minus of cosecant x into cot x whole by cosecant x minus cot x dx. Is it clear? So this is in the form of f dash of x by f of x. So the derivative of cosecant x, the derivative of the cosecant x is minus cosecant x cot x. The derivative of minus of cot x derivative is minus cosecant square x. Minus into minus plus. Now we have to compare with this one, f dash of x by f of x into dx. Integral f dash of x by f of x into dx. This is, we know that, log mod of f of x plus c. This is the log mod of f of x plus c. Therefore, we can write this is log mod of cosecant x minus cot x plus c. This is the formula. This is the log mod of cosecant x minus cot x. Since this is f dash of x by f of x into dx. Integral f dash of x by f of x into dx. This is the log mod of f of x plus c. Log mod of f of x plus c. The first one is complete. And now prove that the second part, log mod of tan of x by 2. We know that the cosecant x is the reciprocal of the sine. Cosecant x is the reciprocal of sine. And cot x is the cos x by sin x. Therefore, we can write this is log mod of 1 by sin x. The reciprocal of cosecant is 1 by sin x. And the cot x is the cos x by sin x plus c. Yes or no? Here cosecant x is the 1 by sin x and the cot x is the cos x by sin x. Therefore, we can write we are taking the LCM is, what is the LCM is here? Sin x. The denominators are equal. Now we have to taking the LCM is sin x. The remaining in the numerator is the 1 minus cos x. Here the remaining is 1 minus cos x. We have to know that the formula of the 1 minus cos theta, 2 sin square theta by 2. 1 plus cos theta, 2 cos square theta by 2. Therefore, in the numerator is there 1 minus cos x. Therefore, that is, we can write here 1 minus cos theta is the 2 sin square theta by 2. Therefore, this is the log mod of 2 sin square theta by 2 is the x by 2. 1 minus cos x is the 2 sin square theta by 2. But the sin x is the 2 sin x by 2. 2 sin x by 2 into cos x by 2 plus c. Is it clear? The 1 minus cos x is the 2 sin square x by 2 and the sin x is the 2 sin x by 2 into cos x by 2. Therefore, now we can write this is sin square is the 2 times of sin. Now 1 time cancel. Now we are getting here log mod of sin by cos is the tan of x by 2 plus c. Therefore, sin x by 2 by cos x by 2 is the log mod of tan x by 2 plus c. Therefore, we can write the log mod of sin by cos is the tan x by 2 plus c. This is the formula of integral cosecant x. That first one is log mod of cosecant x minus cot x plus c, and another one is log mod of tan x by 2 plus c. These are the today we are know that first one integral of tan x, after that integral of cot x, next integral of secant x, now integral of cosecant x. Okay, right. So I can remind you the all trigonometric ratios, the all integrals of the all trigonometric ratios. We know that in first year the trigonometric ratios are sin theta, cos theta, tan theta, secant theta, cosecant theta, cot theta. These 6 are the trigonometric ratios. We know that in the first year in the differential calculus the derivative of sin x is cos x, the derivative of cos x is minus sin x, the derivative of tan x is the secant square x, the derivative of the cot x is the minus cosecant square x, the derivative of secant x is the secant x tan x, the derivative of the cosecant x is the minus cosecant x cot x. Therefore, now we can once again I remind you the formulas of integral formulas of the trigonometric ratios. Therefore, first the integral of sin x. The integral of, all of you listen carefully, the integral of sin x is the minus of cos x plus c. This is the first one. Integral of sin x into dx is the minus of cos x plus c. Now the second one, integral of cos x. Integral of cos x dx is the sin of x plus c. Now we know that the integral of tan x dx. The integral of tan x dx is the log mod of secant x plus c. This is the log mod of secant x plus c. Now we are going to the integral of cot x. Sin, cos, tan, cot. Integral of cot x dx is the log mod of sin x. This is the form log mod of sin x. Just now we prove that the integral of cot x dx is the log mod of sin x. Now the integral of the secant x. Integral of secant x dx. This is, we know that the log mod of secant x, the log mod of secant x plus tan x plus c, and the log mod of tan pi by 4 plus x by 2. Log mod of tan pi by 4 plus x by 2 plus c. Now we are going to the integral of cosecant x. Integral of the cosecant x dx. Integral of the cosecant x dx. This is the log mod of cosecant x minus cot x plus c. Is it clear? Here the log mod of cosecant x minus cot x and also log mod of tan of x by 2 plus c. These are the 6 trigonometric ratios. Integral of sin x dx is the minus cos x plus c. Integral of cos x dx is the sin x plus c. Integral of tan x dx is the log mod of secant x plus c. Integral of cot x dx is the log mod of sin x plus c. Integral of secant x dx is the log mod of secant x plus tan x plus c. Integral of cosecant x is the log mod of cosecant x minus cot x, or log mod of tan x by 2 and log mod of tan pi by 4 plus x by 2. Now we are also know that the derivative of tan x is secant square x. That's why we are know that the integral of secant square x dx is the tan x plus c, and the integral of cosecant square x dx we have to know that minus of cot x plus c. Therefore derivative of tan secant square, the derivative of minus cot x is cosecant square x. Then also we know that the derivative of secant x is the secant x tan x. Therefore we can write the integral of secant x into tan x dx is the secant x. Therefore antiderivative, we know that integral, antiderivative, primitive, these are all nothing but integral. Therefore the derivative of secant x is secant x tan x. Now the integral of secant x tan x is the secant of x. Now the integral of cosecant x cot x dx is the minus of cosecant x minus of the cosecant of x plus c. These are all the very important formulas. Okay, understand? So these are the formulas. So now we are going to discuss the 9 standard integrals. These are very important formulas. 9 standard integrals. These are very important formulas. The 9 standard integrals are: the first one, integral 1 by a square plus x square, a square plus x square dx, and another one 1 by x square minus a square and a square minus x square. These are the 3. And that integral of root of a square minus x square and 1 by root of a square minus x square. After that x square minus a square and 1 by root of x square minus a square, then x square plus a square and 1 by root of x square plus a square. These nine are called the important, that means 9 standard integrals. 9 standard integrals. These are the first of the 3. After that 2, 2, 2, total 9. Therefore, but we are thinking, suppose here there a square plus x square. This is not a formula. We can take here, these are the 2 terms. Integral a square plus x square. How to evaluate this one? This is compared with f plus g. But this is not a f plus g. This is not a f minus g. But here we are the between the algebraic sign between a square and x square. Now this can be written as a square into 1 dx plus x square into dx. This is the a square x plus the integral of x square into dx. X square into dx is the x square integral is x cube by 3 plus c. Is it okay? Now the another one is a square minus x square. We can take minus sign. Suppose x square minus a square is there. How to evaluate this one? We can take this is compared with f minus g. The integral of f into dx, f of x into dx minus g of x into dx. Now this can be integral of x square dx minus a square into 1 dx. Therefore, this is x cube by 3. 2 plus 1 is the 3. X cube by 3 minus a square x plus c. This is the formula. X cube by 3 minus a square into x plus c. Therefore, now we can evaluate these 9. These 9 are called the standard standard integrals. Before that, we are going to discuss some standard substitutions. Standard substitutions. Before that, we are going to discuss some standard substitutions. Therefore, integrand and the substitution. Integrand and substitution. So here suppose integral root of a square minus x square or 1 by a square minus x square is there. How to evaluate this type of? So here we are taking the suitable substitution for x is x equal to we are taking a sin theta or x equal to a cos theta. This is enough. Either you are taking x equal to a sin theta or x equal to a cos theta. When we are taking x equal to a sin theta, this is a square sin square theta. But then you are taking the common factor is a square. This is completely 1 minus sin square theta. Therefore, a square into cos square theta. Now this is a cos theta. This is converted into a cos. This is 1 by a cos. That's why the either a square minus x square or 1 by a square minus x square, we have to take the suitable substitution is the x equal to a sin theta or x equal to a cos theta. A cos theta. Now we are going to discuss the second one, 1 by a square plus x square and a square plus x square root, and another one is 1 by a square plus x square. We are thinking, suppose if you taking x equal to a tan theta, a square plus a square tan square theta. It is the common in that a square. We know that 1 plus tan square theta is the secant square theta. We know that secant square theta minus tan square theta equal to 1. Therefore, 1 plus tan square theta is the secant square theta. And another one is also cos h square x minus sin h square x equal to 1. We know that cos h square x plus cos h square x is the 1 plus sin h square x. When we are taking the a square is the common, then we are getting 1 plus sin h square x. 1 plus sin h square x is the cos h square of x. Therefore, in this case the suitable substitution is x equal to a tan theta or x equal to a cot theta or x equal to a sin h theta. Here we are taking either a tan or a cot, a cos h, a sin h theta. Now we are going to the another one is integral root of x square minus a square and 1 by root of x square minus a square. In this case, we know that secant square theta minus 1 is the tan square theta. That's why we are taking x equal to a secant theta. And also we know that cos h square theta minus 1 is the sin h square theta. Therefore, in this case, we are taking x equal to a secant theta or x equal to a cosecant theta or x equal to a cos h theta. When the integral is in the form of x square minus a square, we can take a secant or a cosecant or a cos h theta. These three are the very important. Then after that, either you can take a suitable substitution or another also general method is there that will be in the coming in the next exercises. Therefore, coming exercises. Therefore, first we are discussing about the under root a minus x by a plus x. So, or a plus x by a minus x. These type of integrals, how to evaluate, that means we are taking the rationalizing method. Root of a minus x by root of a minus x. Then it will be go to the types of the integrations. Types of the 10 types are there. They will coming in the next exercises. Therefore, those are very very important in the board and mains point of view also. Therefore, so this is the another method is there. One of the substitution method. That method will come in the next exercises. The substitution method, we know that in the differential calculus also, x we are taking cos 2 theta. X equal to a cos 2 theta. In this case, x we are taking a cos 2 theta. When we are taking x equal to a cos 2 theta, that is 1 minus cos 2 theta. A is the common, 1 minus cos theta, but the denominator is the 1 plus cos 2 theta. 1 minus cos 2 theta is 2 sin square theta. 1 plus cos 2 theta is the 2 cos square theta. 2 cancel. Sin square theta by cos square theta is the tan square theta. We are getting only tan theta. That is the suitable substitution. Now we are going to the discuss. Another one is x by a plus x under root. At the same time, a plus x by x. We are know that a plus x. We are taking here x equal to a tan square theta. X equal to a tan. Suppose you are taking x equal to a tan square theta, then it is become 1 plus tan square secant square theta. This is the suitable substitution. X equal to a tan square theta. Now write x by a minus x. Now another one, the another substitution is x by a minus x. X by a minus x or the a minus x by x. What you are thinking here? X you are taking a sin square theta. In this case, x equal to a sin square theta or x equal to a cos square theta. If you are taking a sin square, here we are taking a sin square. That is, a is the common, 1 minus sin square. 1 minus sin square theta is the cos square theta. Denominator is a sin square theta. Cos square by sin square is the cot square theta. Square root cancel. That is our suitable substitution. Now we are going to the another substitutions. Those are the first one, root of x minus a. Root of x minus a by b minus x. And the root of x minus a into b minus x, and 1 by root of x minus a into b minus x. So these are the three, x minus a by b minus x minus a into b minus x, and x minus a into b minus x. These are traces. We have to take only the x equal to a cos square theta plus b sin square theta. We are taking in this case x equal to a cos square theta, b sin square theta is the suitable substitution. X equal to a cos square theta plus b sin square theta. Suppose if you forget the suitable substitution, we are taking the into root of x minus a by root of x minus a, then it will be coming into the types of the integrals. In the further exercises, coming exercises, we have to know the 10 types of the integrals. Therefore, these are very important. These 10 types are very important in board and mains and advanced also. Therefore, in the coming exercises, we will definitely discuss those 10 standard types of the integrals. Therefore, here, suppose the suitable substitution in this case is the x equal to a cos square theta plus b sin square theta. Now we are going to discuss x minus a by x minus b. In this case, we have to take only a secant square theta minus b tan square theta. X minus a by x minus b, or x minus a, here b minus x is there, x minus a into x minus b. Therefore, these type integrals we are taking x equal to a secant square theta minus b tan square theta. This is the suitable substitution. Finally, one is there, that is the x minus a into x minus b. In this case, we have to take only x minus a t square or x minus b t square. One of them, any one of them, we have to take t square. Then we can resolve it. We can then we can evaluate that integral. These are the suitable substitutions. First two three are the important. Okay, understand? Now we are going to now we are going to discuss about the 9 standard integrals. 9 standard integrals. The first one, in that the first one is the integral 1 by either x square plus a square or a square plus x square. The first one is either a square plus x square or x square plus a square. This is the 1 by a. It's very important formula. 1 by a tan inverse of x by a plus c. The integral 1 by a square plus x square into dx is the 1 by a tan inverse of x by a plus c. Okay. Therefore, its solution is, all of you listen here. What is the suitable substitution? We know that put x equal to, we know that the x equal to a tan theta. X equal to a tan theta. Therefore, x is the a tan theta. Now the derivative of x is the dx. The derivative of the x is the dx. A into the derivative of tan theta is the secant square theta. Derivative of theta is d theta. Therefore, now these are all substitute in that. What is the given integral is 1 by a square plus x square into dx. That is integral 1 upon a square. The x square is, we are taking x is a tan theta. That is x square is a square tan square theta. A square tan square theta. What is the dx is? Dx is the a secant square theta. A secant square theta into d theta. Therefore, we can write 1 by a square is the common. 1 plus tan square theta. A square is the common. 1 plus tan square theta. A into secant square theta d theta. That is 1 plus tan square theta is the secant square theta. We know that 1 plus tan square theta is the secant square theta. That is a into secant square theta by 1 plus tan square theta is the secant square theta. That is a square into secant square theta. Therefore, d theta. Secant square theta is cancelled. Now we are getting one time a cancel, 1 by a. 1 by a integral 1 into d theta. Integral 1 into d theta. That means that is 1 by a. Integral of 1 dx is the x. 1 dx is the x. Therefore, we can write the here the integral 1 by a. 1 into d theta is the theta plus c. 1 into d theta is the theta. What is the theta here? We can write tan theta equal to x by a. Is it okay? Tan theta is into a is the by a, x by a. Now we can write theta equal to tan inverse of x by a. Tan standing other side, it will be tan inverse of x by a. Therefore, now we can write 1 by a, where theta is the tan inverse of x by a plus c. This is our solution. So first of all, we have to take x equal to a tan theta, the derivative of tan secant square theta. We are substitute x equal to a tan theta, that means a square tan square theta. Dx is a secant square theta. Then you take the common term is a square. 1 plus tan square is secant square. These are cancelled. We are getting 1 by a. 1 into d theta. Integral 1 into d theta is the theta. 1 into d theta is the theta. Theta is the tan inverse of x by a. This is our required solution. 1 by a square plus x square into dx is the 1 by a into tan inverse of x by a plus c. Is it okay? The second one, integral, evaluate the integral 1 by 1 upon a square minus x square dx. Integral 1 upon a square minus x square into dx. This is the 1 by 2a log mod of a plus x upon a minus x plus c. That is 1 by 2a log mod of a plus x by a minus of x. These are very important 9th standard integrals. So this is the form 1 by 2a log mod of a plus x by a minus x. How to write this one? Now we can write the integral of, now its solution is integral of a square minus x square dx. This is we know that the integral 1 by a plus x into a minus x whole of dx. This is compared with a square minus b square is the form of a plus b into a minus b. Is it okay? A plus b into a minus b. Now we are right here. This can be written as a plus x plus a minus x whole by a plus x, a minus x. This can be written as, we can write also a minus x, a plus x. This is the a plus x into a minus x whole of dx. Is it clear? Minus x plus x are cancelled. A plus a 2a. Now we can write 1 by 2a. Okay, is it okay? Here the NR is there 1. Numerator is 1. Therefore we are taking a minus x plus a plus x. X plus x minus x are cancelled. A plus a 2a. 2a by 2a is the 1. Now after separation, therefore we can write 1 by 2a integral. This one by this one. We can write the 1 by a plus x. Is it okay? Here a minus x by a plus x into a minus x. These two are cancelled. Now after that, this one by this one. A plus x by a plus x is cancelled. Now the remaining is a minus x dx. Is it okay? So now we can write here, we are thinking this is f of x, this is g of x. The algebraic property is f of x dx plus integral g of x dx. Therefore, this is, we can write 1 by 2a, the integral 1 by a plus x dx. After we can write this is integral 1 by a minus x, 1 by a minus x dx. We have to take separately integrals. Therefore, 1 by a plus x dx plus 1 by 1 upon a minus x dx. Then you can write, this is the 1 by 2a integral, the derivative of a0, derivative of x is the 1. This is, we have to compare with f dash of x by f of x. F dash of x by f of x. When it is the f dash of x by f of x, this is the formula of log mod of f of x. That is, log mod of f of x is the a plus x. Is it clear? Okay. The derivative of a is 0. The derivative of minus x is minus 1. Now this can be written as minus into minus. This can be written as minus 1 by a minus x dx. Okay, understand? We can take in the step we have to take the second term is a multiple with minus into minus is the plus. Because the derivative of a is 0. The derivative of minus x is minus 1. Therefore, we are taking minus 1. Before that, we are taking minus. Minus into minus is the plus. Minus into minus is the plus. Therefore, after that, this is the 1 by 2a log mod of a plus x minus of log mod of, this is the f dash of x by f of x. F dash of x by f of x is the log mod of f of x. Log mod of f of x is the log of a minus x. Finally, we take integral constant. 1 by 2a log a minus log b. Log a minus log b is the log of a by b. Log a minus log b is the log of a by b. Therefore, this is the log of a by b is the log of a plus x minus a minus x. Log a minus log b is the log of a by b. Therefore, this is our required solution. Is it okay? First you can write a square minus x square is the a plus x into a minus x. Then we are taking between the plus a minus x plus a plus x. These two are cancelled. A plus a 2a, then we taking by 2a. After separation we are getting these two are cancelled 1 by a plus x. These two are cancelled 1 by a minus x. Then you can write separate. We have to take integral separately. Then it is f dash x by f of x is log mod of f of x. This is also f dash of f of x is log mod f of x. Log a minus log b, log of a by b. This is the formula of integral 1 upon a square minus x squared dx. A square minus x square dx is the 1 by 2a log mod of a plus x upon a minus x. 1 by 2a log mod a plus x by a minus x plus c. Now we are going to discuss the third one. Integral 1 by x square minus a square dx is the 1 by 2a log mod of x minus a by x plus a. Log mod of x minus a by x plus a. 1 by 2a log mod of x minus a by x plus a. Now this is just 1 minute. This is, we can write integral 1 by x plus a into x minus a. This is the formula of a minus b into a plus b. A minus b into a plus b. Is it okay? Okay. This is a plus b into a minus b. A square minus b square. A square minus b square. Now this can be written as, how to write this one? Okay, all of you listen here. X plus a minus of x minus a. Is it okay? 1 by 2a. Is it okay or not? X is cancelled. Minus of minus plus a. A plus a 2a. 2a by 2a is the 1. Therefore, the denominator is the x minus a into x plus a dx. Therefore, we are taking the numerator is x plus a minus x minus a upon x minus a into x plus a. Therefore, this is 1 by 2a integral. This can be written as, after separation, we can write x plus a or the cancel. We getting x minus a dx. Now this is integral. We are getting here, these two are cancelled. 1 by x plus a dx. So now we are right here 1 by 2a. This is the formula of log mod of x minus a. 1 by x dx. Integral 1 by x dx log mod x. Integral of 1 by x dx is the log mod of x. Since derivative of x1, derivative of a 0. This is the log mod of x minus a. This is also the derivative is 1. This is also compare with f dash of x by f of x. This is also formula of log mod of x plus a. Finally, we take the integral constant is the c. Now we can write 1 by 2a log mod of log a minus log b. Log a minus log b is the log a minus log b is the log of a by b. That is the x minus a by x plus a plus c. Okay, log a minus log b. This can be written as, here we can write 1 by 2a log a minus log b. 1 by 2a log a minus log b is the log mod of a by b. X minus a by x plus b plus c. Log of x minus a minus log of x plus a is the log of x minus a by x plus a plus c. Okay, this is the formula of integral 1 by 1 upon x square minus a square into dx is the 1 by 2a log mod of x minus a upon x plus a plus c. But the integral 1 upon a square minus x square is 1 by 2a log mod of a plus x by a minus x. But the integral 1 upon a square plus x square into dx is the 1 by a tan inverse of x by a. So today we are completed 3 of the 9 standard results. We are 3 completed. This is today. Tomorrow, let us continue tomorrow in the tomorrow class. So the only the remaining 9 remaining are the 6 standard integrals are there. Okay, thank you all.